Math 1130, section 4.4, properties of logarithms. Okay, so in the previous section, we talked about logarithms, and logarithms are the inverse or opposite to exponents. Now, the same way we have rules for exponents, we also have rules for logarithms. For example, if we have x to the a times x to the b, anything with the same base, if we multiply, we add the exponents. Now we have a similar property for logarithms that says if you have the log base b of a product xy, that's equal to log base b of x plus log base b of y. So if you take the log of a product, you can turn that into a sum, log of this plus log of this. Now, what we're going to be doing today is going back and forth between these rules. Sometimes the directions will say expand, and we want to write it as a series of logarithms, or it'll say condense, where we want to simplify into a single logarithm. Now, what you want to do depends on the problem. For this class, a lot of times we want to simplify, so we'll condense. Later, when you go to calculus, you'll want to expand, so you can differentiate and integrate these separately. The next rule, remember, if you divide things with the same base, you subtract the exponents. For logarithms, log base b of x over y equals log base b of x minus log base b of y. So if you're dividing two things, we can turn that into a difference. Now, the last rule we have with exponents, if you have an exponent raised to an exponent, you multiply. For logarithms, log base b of x raised to the p. P is just some number, x raised to some exponent. The log property says if you have this raised to some exponent, you can take this exponent and move it to the front to the multiplier. P times log base b of x. Now, again, remember this number right here. Once we move it to the front, this still means multiplication. This number right here is not glued to the logarithm. Let's look at some examples of that. Let's say I have log base 2 of 8x. Well, this is a product. What I'm going to do is rewrite this as log base 2 of 8 plus log base 2 of x. This is multiplication. I turned it into addition. Okay, now, it doesn't mean we're done yet. Let's see if we can simplify. These are numbers, log base 2 of 8. Can I convert that? Well, do what we did in the previous class. Say log base 2 of 8 equals n. And n is just something I made up. Equals 2 is the base. I'm putting it in exponential form. To the n equals 8. Now this is something we can do. We can say, okay, what works here? N equals 3. 2 to the third power equals 8. Therefore, n equals 3, which means all of this is equal to 3. So the solution is 3 plus log base 2 of x. Okay. Next question says natural log of 5xy. Now this is natural log, but natural log is still a log, and we still have all the same log properties in place. So if I have this times this times this, I can rewrite this as natural log of 5 plus natural log of x plus natural log of y. And then we can't do anything else. We could put natural log of 5 in the calculator, get some decimal. I think I'll just leave it the way it is. Log base 6 of 8 over t. This is division. I'm going to turn that into subtraction. I'll say log base 6 of 8 minus log base 6 of t. Now you're looking at this and you're thinking about the other problem and you're thinking, can we simplify this? Maybe. Log base 6 of 8 equals n. 6 to the n equals 8. Now, yes, there is some value of n that makes this equation make sense, but it's not a whole number. 6 to the first or 6 squared is not going to make 8. I'm just going to leave this as is. Later, we'll discuss how to solve an equation like this, but at the moment, just leave it as log base 6 of 8, and we're finished with the expression. Let's look at one more example with natural log. Natural log of e to the 12th. Now, in the previous class, we talked about natural log and e, and they cancel out. Now, be very careful. It's very tempting to cancel right now, but we can't. What we have to do first is say this is natural log of e minus natural log of 12. Natural log of e, well, you probably know what that is. We can check on the calculator. The natural log of e, specifically e to the first, is 1. You can think of this as exponent 1. Natural log and e cancel out, leaving 1 minus natural log of 12. Again, we can put this in the calculator and get a decimal. I think this is a sufficient answer here. Let's do an example with common log. Log of x over 1,000. Now, just like the other examples, this is division. We'll write this as subtraction. Now here, you know that common log is base 10. Now you could say 10 to the n equals 1,000, and then you would know n equals 3. But because it's common log, we can actually put it in the calculator and say log of 1,000 equals 3. Therefore, this expression is equal to log of x minus 3. Okay, let's look at some more complicated examples of that. Let's say I have log base 2 of z cubed over x, y to the 5th. Now here, we've got a product, and we also have a difference. No, I'm sorry, a quotient. This divided by this. What you should do first is deal with the quotient first. Say log of this minus log of this stuff. So I'm going to say log base 2 of z cubed minus log base 2 of x, y to the 5th. Now these parentheses are optional here. I'm just showing that, okay, we did the top minus the bottom here. Now we can't really do anything with this. Look at this. This is a product. However, you have to remember that you're doing subtraction. This is minus all of this stuff. So yes, we can turn that into minus log base 2 of x plus log base 2 of y to the fifth, using our product to sum property. This is fine. This is as expanded as this is going to get. If you want to distribute the negative, negative times this, and we're done. What happens a lot of times is students will turn this into sum and they'll say plus right here. But you have to remember that you're subtracting all of this. So it's minus times all of this to get this. Now you might be wondering, what do we do with the 3 and what do we do with the 5? Can we use our log property that says move it to the front? And the short answer is you absolutely can. There's no difference between these two solutions. It's not more expanded or simplified to move this to the coefficient. Okay. Let's look at log of the square root of x plus y, the whole squared, over 10. Now, you can see a quotient here, stuff divided by some other stuff, but we're kind of blocked in by the square root. Let's turn the square root into a number. Remember, the square root is the same thing as 1/2 exponent. Now, this would be a time where we use our log property. We're going to take this 1/2 exponent over here, and we're going to move it to the multiplier. We're going to move it to the front. So I'm going to say this is equal to 1/2 log of x plus y squared over 10. Now that that 1/2 exponent is out of the way, now I can turn this into subtraction. Now let's be careful here. Like I said, this 1/2 is not glued to the logarithm. This is 1/2 times. If I turn this into 2 logarithms, I have to say 1/2 bracket Now, whether you use bracket or parentheses is up to you. I want to make it very obvious that it's 1/2 times everything. Now, if you look at what happens inside the bracket, we can do the same thing with this 2 exponent. We're allowed to move that to the front. Here, well, this is common log, right? Base 10. Calculator, what is the log of 10? 1. So what I'm going to do is I'll say 1/2. Move this 2 to the front. 2 log of x plus y minus log of 10 is 1. Now this is about as simplified as this is going to get. If you really want to, you can distribute 1/2. That's about as simplified as it's going to get. If you really wanted to, you could write this whole expression over 2 instead of 1/2, but that would be the same thing. Okay, now everything we've done so far has been expansion. We take a single log expression and we make it as big as possible. Let's go the other direction and condense some log expressions. Let's say log base 2 of 560 minus log base 2 of 7 minus log base 2 of 5. Now, you might be very tempted to turn this into a whole number. Does that even work? Well, I don't think so. But the short answer is you don't want to do that because you want everything to be the same log base. Because if they are the same, then we can combine them together. Let's do this. Let me write this as log base 2 of 560 minus bracket the quantity of log base 2 of 7 plus log base 2 of 5. Now, why would I do that? Well, what that creates is addition. And we know addition turns into multiplication. So I can rewrite this as log base 2 of 560 minus the quantity of log base 2. This times this, addition becomes multiplication, 35. This is subtraction, turns into division, this divided by this. No, this is still a ratio or a fraction. I can simplify that. 560, I know 5 goes in there. Log base 2 of 112 over 7. Now you might be tempted to try to do some transformation here. Maybe expand this. Well, the short answer is we can't. If you were to say log base 2 of 112 minus log base 2 of 7, those can't be simplified into whole numbers, so it's not worth it. This is as condensed or as simplified as it's going to get. Now, this is how I did the problem. Another student might come along and do this. Log base 2 of 560 over 7 minus log base 2 of 5, which is allowed. You can do this, which then becomes log base 2 of 560 over 7. This is subtraction, becomes division, divided by 5. Now this is a little wonky looking. This is a little difficult to simplify. This is the same thing as 560 over 7 divided by 5, which is the same as 560 over 7 times 1/5, which is 560 over 35, which is the same thing we got. This approach is a little less straightforward to me. Having to do this divided by this can confuse students. That's why over here I tried to create some addition so that we get multiplication and then divide. Let's try another one like that. 3 log A minus 1/2 log B minus 1/2 log C. Now here, before we jump in and start using our rules, I notice that there's a 1/2 here and 1/2 here. You could use the rule that says move it to the exponent, and you could. What I think I'm going to do is factor out a negative 1/2. Same as the previous problem, it'll create some addition. Let me say 3 log A minus 1/2 the quantity of log B plus log C. And what you create is very nice. You have addition. You have addition, turn it to multiplication, log of B times C. Now you kind of have this 3 and this 1/2 that are in the way. Let me move those to the exponent. Let me move the 3 up here. Let me move the 1/2 up here. Now you might be tempted to use negative 1/2. I think that would complicate things. Just leave it as 1/2. Log of A raised to the 3rd power minus log of BC, the quantity, raised to the 1/2 power. Now that you have Subtraction, turn that into division. Log of a cubed over log, nope, BC to the 1/2. Now, if you really wanted to, you could make that log of a cubed over square root of BC, because that's the same thing as 1/2 exponent. It really doesn't matter. All right. Let's do a similar problem involving natural log. 1/2 natural log of x plus the natural log of x squared minus 1 minus the natural log of x plus 1. Now everything's natural log, so we have the same base, which means we can use the properties. Let me do this. This is addition. I want to turn that into multiplication, but before I do that, let me move this 1/2 up here. Natural log of x to the 1/2 plus natural log of x squared minus 1 minus natural log of x plus 1. Now that that's kind of tucked away, now we can say, okay, this is addition, turn it to multiplication. Natural log of x to the 1/2 times x squared minus 1. Now these parentheses really aren't necessary here. I'm just showing that it's the natural log of this times this. Now that we have subtraction, turn that into division, the natural log of x to the 1/2 times x squared minus 1 divided by x plus 1. Now this is okay. We've used all of the log properties to condense this, but I know what you're feeling. You're looking at this x squared minus 1, and you really, really want to factor that, which would be smart. X to the 1/2 times x plus 1, x minus 1, x plus 1. And look at what happens. This actually cancels out, leaving us the natural log of x to the 1/2 times x minus 1. I think that's a simplified enough form. If you really wanted to, you could distribute this. That'll be kind of busy looking. If you really wanted to, you can say x to the 1/2 is square root of x times x minus 1. Again, this is all pretty much the same thing. All right, that is using the 3 basic properties of logarithms. Let's look at another helpful log property. We're going to look at the change of base formula. Now, this is going to be very helpful for us because our calculator only speaks log and natural log. If it's base anything else, base 2, base 10, base 3000, we have to do something else. What the change of base formula says is that if you have log base b of x equals log base a, it's not right. Yes, log base a of x over log base a of b. Now I know this is very confusing looking. Log base b of x equals log base a of x over log base a of b. Well, what this a is, a can be anything. It can be 1, it can be 10, it can be e, it doesn't matter. What this does is you say the log of this divided by the log of this. Now that's very helpful because what that means is if the base can be anything, I can choose base 10, which means, okay, I can say common log. So if I want to change this in terms of log, a language my calculator speaks, I can say log of this divided by log of this. And again, since the base doesn't really matter, you can use natural log if you want to. You'll still get the same thing. Let's look at an example of that. You know, earlier we were looking at a problem that said log base 2 of 8. And what we did is we created a variable n, and we said 2 to the n equals 8, therefore n equals 3. And we kind of had to guess that mentally. With the change of base formula, I can do that in the calculator. I can say log base 2 of 8 equals log of this over log of this, log of 8 over log of 2, which is nice because I can let the calculator do the work. Now be careful with log, it'll auto-generate some parentheses in the calculator. I want to say log of 8, close, divided by log of 2. And there we go, we get 3. So rather than having to do this mentally, I can just say, okay, this is 3. So let's look at this. Log base 3 of 7. Now if I try to do this mentally, 3 to the n equals 7. Well, that doesn't work because 1 is 3, 2 is 9. It's somewhere in between there. To figure out what this is exactly, what I'm going to do is say log of 7 divided by log of 3. Log of 7 divided by log of 3. Now we'll get a decimal, and that's to be expected. We know that this is somewhere between 1 and 2. I'm going to say this is approximately equal to 1.77. Pay attention to the homework and exam directions. They'll tell you how many places to round to. Let's say I have log base 12 of 8. I can convert that to log of 8 over log of 12. So on the calculator, log of 8 divided by log of 12. 0.84. Now remember, we said the base doesn't matter. You can use log or natural log. In this case, if I did natural log of 8 divided by the natural log of 12, well, notice we get the same answer either way. Really, I should say that's approximately. It's not exactly equal to that decimal. Log base 3 of 91. Well, I'm going to change that into log of 91, log of 3, log of 91 divided by log of 3. 4.11. Now, I know what you're asking. Why is this important? Why do we need to be able to do something like this? Well, what we're going to do in the next class, we're going to deal with word problems. And you'll solve equations, and you'll get an answer like x equals 2 log of 7 of 12. Now, if this is your answer, this could be 2 log base 7 of 12 minutes. Now, we have no idea what that is. 2 log base 7 of 12 minutes? Well, we can go to the calculator. I can use the change of base formula. I can say log of 12 divided by log of 7. Now notice it's 2 times, so I'm going to say times 2. So I know my answer is approximately 2.6 minutes. Now this is a word problem answer that actually makes sense to us. And that's something we'll talk about in a future class.